We are looking at the sketching of parabola graphs, very important. Some of your basics from previous grades is crucial here. Finding x-intercepts, finding y-intercept, remember how the calculations go, and then you go ahead and actually solve any equations that come out of that calculation in order to be able to find what you're looking for. Remember, there's a turning point in a parabola, so you also need to find a turning point. So let's go. Right, let's look at our first example. Y is equal to 2 into x minus 3 all squared minus 8a. Very important to look carefully at your equations. We can see that our equation 1 has a value of a that is positive. Secondly, this is the equation that is in the standard form where we can see the turning point coordinates. And here you can see clearly what those values would give us in terms of the turning point. And just watch out again for the x coordinate of that turning point, which we'll mention just now. Now, clearly, x is 3 and y is negative 8. Just watch out again because the value of p is actually 3 there. If we had x plus 3, then it would mean that the value of x there is negative 3. And also it's pretty easy. If you just take the x minus 3 expression inside, equate it to 0, and then solve for x, and you'll get the actual value of x you're looking for. All right, so let's go. We need a y-intercept. That's pretty easy. Substitute x as 0 in your equation and then solve for y, which gives us y is equal to 10. So that means now on our Cartesian plane, we know the graph is cutting the y-axis at 10. In the parabola graph, we'll always have a y-intercept as long as we're still doing grade 11 parabolas and no inverses. So let's go. Now, we've got a turning point. We know with the value of a that, oh, we expect a graph that is facing up because our a is positive. So that immediately gives us an idea that, oh, our graph is turning below the x-axis and is facing up. It's definitely going to cut the x-axis. We then need to find out what are these x-intercepts? What are these values where the graph is cutting the x-axis? And that's pretty easy. We go to our equation, substitute y with 0 as we always do with all graphs when we're looking for the y-intercept. X-intercept, we substitute y as 0. Now, I've already multiplied out my equation because I'm creating a quadratic equation here. So I multiplied what I was given and I ended up with this equation. Substituted y is 0 and now I solve. And it's pretty easy. Factorize, then you get your x-intercepts, and right there is your graph ready for sketching. It's got all the intercepts, x and y, and the turning point. And that will give us a sketch that looks like that. And you're done. It's pretty easy, but your skills on solving equations need to come in handy there so that you're able to get what you're looking for. Right, here's our next example. Y is equal to negative 2x squared plus 3x minus 2. Now here again, we've got a standard form of a parabola that you can expect of y is equal to ax squared plus bx plus c. In this standard form, we easily determine the y-intercept, which is the value for c. In this case, it's negative 2. We can also see the value for a, where you know that if a is positive or a is negative, the graph is facing up or down. In this case, it's negative, the graph is facing down. Great. We just need to work out what is missing so that we can sketch our graph. So our y-intercept, as I said earlier, is negative 2. That is done, no effort. Really just have to look because the graph is in the standard form. So we know the graph is cutting the y-axis at negative 2. Now, we are not able to see the coordinates of the turning point like we did with the graph that had a turning point form. So now we need to work it out. And one of the things that is important here is the formula that we get from the axis of symmetry, which is negative b over 2a. And that formula would help us determine the x-coordinate of the turning point. And then we easily use that to determine the y of that same turning point by substituting in the original equation. Substitute your x-coordinate and the result is your y, which in this case is negative 7 over 8. So we now know we've got a turning point at 3 over 4 and negative 7 over 8. And take note, we've already seen, looking at our a, that we're expecting a graph that is facing down. So this graph is never ever going to touch the x-axis because it's turning at that point below the x-axis and is facing down. And therefore, it's easy then to tell that we don't even need to do calculations for the x-intercepts. We can just simply sketch our graph because we've got everything we need, and that is it. But of course, it's important to know extra information on this. When a graph has real roots and when a graph has non-real roots, what are you expecting? Now, in our equation, when we check using delta, we notice that, oh, our delta is negative 7. Hey, that graph has got non-real roots. It will never touch the x-axis. But if we had found that our value for delta was either greater than 0 or equal to 0, then we'd have known that, oh, we've got real roots now. The graph will definitely touch the x-axis. And that other information will come later where we explore more of that. But it's important just to add on your knowledge of the nature of roots in order to help you determine other things. So you would have been able to tell whether the graph has got x-intercepts or not. So you don't waste time working out the x-intercepts when there's none. However, let's assume somebody had gone on to work out the x-intercept. You would have actually ended up in your quadratic formula with a situation where under the square root you've got a negative value of 7. So then you would have been able to tell right there that, oh, I've got no roots here, or I've got non-real roots. So therefore, the graph will not touch the x-axis. Here's another one. Y is equal to x squared minus 4x plus 1. Easily, we determine the y-intercept. It's cutting the y-axis at 1. We can see that because the graph is in the standard form. And then, working out the turning point, we immediately determine that the x is equal to 2, which means that's the x-coordinate of your turning point. When you find the y is equal to negative 3. So we know now that our graph has a turning point at 2 and negative 3. And based on our value of a, the graph is facing up. And if that graph is facing up, it's definitely going to cut the x-axis because it's turning below the x-axis and it's facing up. And we expect a shape of some sort. But ultimately, we want to know what are those x-intercepts where the graph is cutting the x-axis. And that's where you bring in your knowledge of solving for x-intercepts by substituting y as 0 and solving the equation that comes out. It so happens that this particular equation is not factorizable. And that's the reason I was bringing this example, that don't expect everything to come out nicely for you and you got equations that work out nicely because they're factorizable. Sometimes you're going to come across these equations. As long as you've got the quadratic formula, we'll be able to determine those x values. And you substitute in your formula and you find, using your calculator, the x-intercepts. And in this case, our x-intercepts is 3,73 and 0,27. Hey, we're ready to sketch. We already know the graph is facing up. So just join those points and the intercepts, and we've got a full sketch. Pretty easy and straightforward.